Chapter 3. We'll be talking about the Chevy Asteroid, the characteristics of near-Earth objects, also known as NEOs, impact features, impact hazards, and beware of flying rocks. In 1992, a football-sized meteorite crashed through the trunk of Michelle Knapp's Chevrolet Malibu Classic in Peekskill, New York. Now, if you know anything about meteorites, you should know that they're very, very dense, so this was very heavy, and it's worth a lot of money. The meteorite was probably worth more than her car. Near-Earth objects, NEOs, are asteroids or comets that approach Earth. What are the chances that a larger space object will crash into Earth in the near future? The Barringer crater, also known as Meteor Crater in Arizona, formed approximately 50,000 years ago when a 50-meter diameter meteorite crashed to Earth. If you look at this crater that the meteorite made, it's a lot larger than 50 meters. I've been to this particular crater, and if you look right about in here, there are buildings. You drive up, there's a big parking lot, you have to walk up here, and you can walk the rim of the crater. You can even walk down into the crater. You have to climb down from the rim to the bottom of the crater. You can tell that there's something down there. It's something white, but you're not quite sure what it is because it's a little bit too far to see. I'll tell you what it is. It's a space suit in the bottom of the crater. This crater is located near the Petrified Forest, Flagstaff, Arizona. Earth does carry the scars of past impacts with asteroids and comets. A devastating collision with a 10-kilometer wide asteroid is hypothesized to have caused a global extinction over 65 million years ago, and we will be discussing this extinction. The characteristics of near-Earth objects. Most NEOs do not come close to Earth, but occasionally one may approach within the Moon's orbit. When Apophis sails by Earth, it will be close enough to be visible to the naked eye. It's going to be about 36,000 kilometers away, as close as satellites that orbit the planet, which could mean problems for some of the satellites for sure. The characteristics of near-Earth objects. Few asteroids were recognized in the solar system 100 years ago. Well, think about why. We have a lot better technology now. Galileo's telescope couldn't really see these small asteroids. Look at the difference between this slide, which has very few asteroids shown on it, the little X's, and this slide. 90,000 asteroids have been identified. The little red squares in here, the red ones, are NEOs. The Moon is almost 3,500 kilometers, and this asteroid, which is the largest, 940 kilometers. It's not as large as the Sun. This is the asteroid Eros. Characteristics of these objects, specifically the asteroids, the size. From pebbles up to 940 kilometers in diameter, the asteroid that we just compared to the Moon. They travel at 16 kilometers per second, which is about 36,000 miles per hour. They're made up of rock and/or metals. A meteor is scientifically known as an asteroid that burns up in the atmosphere. At night, you can see them as shooting stars. A meteorite is an asteroid that actually strikes the Earth's surface. It doesn't completely burn up. Comets are larger than asteroids. Many of them are hundreds of kilometers across. They travel way faster than asteroids, 50 kilometers per second or 112,000 miles per hour. They're made up of ice and rock. Icy dirt balls. These icy dirt balls can form a tail as the heat from the sun causes the ice to change from a solid to a gas, and the tail always points away from the sun. The collision of impactor spacecraft with Comet Tempel on July 4th, 2005. An analysis of light from the explosion on Tempel 1 revealed information on comet composition. They found out that common compounds were cyanide, carbon dioxide, and water. Scientists are investigating if comets could have supplied water in Earth's early oceans. Comets. In 1908, an explosion of a comet in the atmosphere over Tunguska, Russia, destroyed forest over an area the size of a major city, 2,100 kilometers squared. Look at the trees in the picture that were knocked down by the comet. Characteristics of near-Earth objects. There are two types of comets: short-period comets and long-period comets. Short-period comets come from the Kuiper Belt way beyond Neptune, and they return to the inner solar system every few years. That's why they're called short-period comets, because the period that they visit us is every few years. Long-period comets originate in the Oort clouds at the outer limits of the heliosphere, and they return to inner solar system over decades to thousands of years. Long-period comets travel toward the sun with irregular orbits that may be at a high angle to planets. Short-period comets orbit the sun with similar paths to outer planets. Which one do you think Halley's Comet is? A short-period comet or a long-period comet? This diagram shows the partial path for an Oort cloud comet. It shows the tail away from the sun, and here's where the Kuiper Belt. Impact features. This is the Barringer crater in Meteor, Arizona, and this is a crater on the moon. They look very similar. Well, there's reasons they look similar. Near-Earth object collisions with rocky planets and moons form two different types of impact craters: simple craters and complex craters. See, scientists aren't all that creative when it comes to naming things. The Barringer crater in Meteor, Arizona, in the top of the picture, was formed 50,000 years ago, and it was the first meteorite crater which was recognized on Earth. If you ever get a chance to go there, it's pretty interesting. It's just outside of Flagstaff. Craters all feature broken rocks, also known as breccia, and ejecta, which is the rocks that are thrown out from the crater as the meteorite hits the ground. They also have melt rocks. They have altered minerals. Simple craters are bowl-shaped, and they're only a few kilometers wide. Complex craters are more than 4 kilometers in diameter, and they have a central peak that sticks up in the middle and ring structures. Look at the difference. The top is a simple crater. It's just a bowl, an empty bowl. The complex has the central peak in the center. So you can imagine meteorite hitting the ground and then kind of jumping back up after the compression because of the energy. It has to go somewhere. For every action, there's an equal and opposite reaction. So it gets compressed down and then it springs back up a little bit, and there's the central peak. There are more than 150 impact craters that have been identified on all the continents. Few impact sites have been identified in the oceans. Why is that? Well, for one thing, we can't see them. Here they are. Here's a map of the discovered impact craters so far. As a matter of fact, we've been discovering lots of new features of Earth just in the last year or so with those new cameras. And even under the oceans, we've been finding things. We found a coral reef off the coast of South Carolina that we didn't know existed until just recently, within the last year. Here are the key buildings of Washington, D.C. The U.S. Capitol is closest to us, and then the National Mall, the long grassy area, and then there's the Washington Monument and Lincoln Memorial behind that. Keep this in mind. The impact of an NEO with a diameter equivalent to the Lincoln Memorial would destroy a large city. That doesn't seem possible, does it? The National Mall collides with Earth every 100,000 years and would devastate most nations. An NEO with a diameter equivalent to the whole National Mall. One the size of DC collides with Earth every 100 million years and would produce global scale destruction. Large NEO impacts are infrequent. Impacts of relatively small near-Earth objects occur at intervals of hundreds to thousands of years. Large impacts occur on timescales measured in the hundreds of millions of years, which is a good thing for us. Here's what it would look like if a 10-kilometer near-Earth object collided with Earth. This is the impact site, and you see this is where the ejecta would come out to, this ring right here. What would happen? There would be a fireball racing through the atmosphere. People at the impact site would only have seconds to live. The air blast would flatten everything for hundreds of kilometers in all directions. Well, look at it. It does go in all directions. Think of dropping a pebble into a smooth lake with the circles, the waves that leave the center, the impact zone. Just like this. The circles, the waves. A massive earthquake would happen at the collision site, and an ocean impact would produce giant tsunamis hundreds of meters high. Molten rock from collision would rain down and start massive wildfires. Huge cloud of dust would block the sunlight, cool the planet for months, and kill off most of the vegetation. The gases from the impact, the sulfur dioxide and the water vapor, would be added to the atmosphere. Beware flying rocks. NEO impacts are the only major natural hazards that we have the potential to prevent. We can't stop volcanic eruptions. We can't stop earthquakes. We can't stop hurricanes. With forewarning, NEOs could potentially be deflected off course or destroyed. Scientists have already hit a comet with a spacecraft and even landed the spacecraft on an asteroid. No, I'm not talking about the movie Armageddon. Armageddon has a lot of bad science in it. Look it up. See what's bad in the movie. Current search programs focus on approximately 1,000 objects with a diameter of more than 1 kilometer. The search programs are looking for fast-moving dark objects against the backdrop of space. The largest NEOs pose the greatest risk and are the easiest to find. Scientists map the position of specific NEOs over time to chart their course relative to Earth. And that's how they can project which direction it's going and how close it will be. This is the Torino scale. The Torino scale works kind of like what we have for hurricanes and for tornadoes. We have, Category 1, Category 2, and it depends on the speed of the wind as to what category they are. Well, here, 0, there'd be no hazard. This is impact predictions. A normal prediction, a 1. Meriting attention by astronomers would be a 2. Now this would be a somewhat close but not highly unusual pass near Earth. The closer the prediction, the higher the number. Certain collisions would be a 10. This would happen every 100,000 years. So a 0 will miss Earth, burn up in the atmosphere. A 1 will pass near Earth, but it's extremely unlikely to impact. 2 to 4 is yellow, a minor chance of impact. 5 to 7, orange, a serious threat of impact, and planning might be warranted. The warning meaning it's coming. 8 to 10 is certain collision. It's coming. Number corresponds to the size of the near Earth object. This concludes Chapter 3.